जी, अस्सलाम वालेकुम class. My name is Engineer Hassanza and today's lecture is lecture number 10 of Engineering Mechanics AGN 2103. Chapter number 4 is going to complete in this lecture. Chapter number 4 is all about structure. What is structure? Structure is basically interconnected, is a system of interconnected members that are used to withstand load or transmit load under the equilibrium conditions. There are many types of structures: plane, trusses, simple trusses, then space trusses, then frames, machines. All these are the different types of structures. Basically, equilibrium conditions are used to solve or to design for different type of structures. Equilibrium conditions are as the summation of forces is equal to 0 and summation of moment is also equals to 0. In terms of summation of forces, it can be in one directional, like in case of plane stresses. In case of space stresses, it can be three-dimensional in x direction, y direction and z direction. And moment, summation of moment should also be equals to 0 to satisfy the condition of equilibrium. So basically, the simplest type of trusses is simple trusses or plane trusses. So what are simple trusses? Simple trusses are composed of two members joined at their ends and they capable of supporting tension or compression. Each internal force there is always in the direction of its members. So simple trusses are basically members in which the three-dimensional in terms of plane trusses and in terms of space trusses quadrilateral or four members are joined together to withstand the load under the equilibrium condition. Simple trusses are built from the basic rigid non-collapsible unit in the form of triangle for plane trusses and tetrahedron for space trusses. So basically there are two conditions for simple trusses, that they are non-collapsible and non-deformable under the action of different forces or strains. Additional units of trusses are found by adding new members, 2 for plane trusses and 3 for space trusses. It means if we are going to increase our number of members, the additional unit, we have to add two members to add a single unit in case of plane trusses, and in case of space trusses we have to add three space members to increase a single unit in a simple truss. The joints of simple trusses are assumed to the pin connection for plane trusses and ball and socket connection for space trusses. Thus the joints can transmit force but not the movement. So basically these are the joint methods in terms of simple trusses, plane trusses. In terms of plane trusses we are going to use beam connection, and in terms of space trusses ball and socket joint is used. External loads are assumed to be applied only at the joints. Trusses are statistically determinate externally when the external constraints are in excess of those required to maintain an equilibrium position. So basically we have studied there are two types of structure: statistically determinate and statistically indeterminate structure. If m plus 3 is equal to 2j, going to satisfy system or the structure going to satisfy this equation, that means our structure is a determinate structure. Then the method of joints, there are two type of methods to solve the equations or numerical problems or real life problems, real time problems for the trusses. So first one is the method of joints. It utilizes the force equation of equilibrium for each joint. Analysis normally begins at a joint where at least one force is known and not more than two forces are unknown for plane trusses, or not more than three forces are unknown for space trusses. It means There are two types of methods to solve the equations for trusses: method of joint and method of section. In terms of method of joint, we start from a joint where at least a single member is known or single value is known, and not more than two members are or the values are unknown. And in case of space trusses, one member or at least one value is known and not more than three values are unknown. And in case of method of section, utilizes a free body of an entire section of truss containing two or more joints. In general, the method involves the equilibrium of non-concurrent system of forces. The moment equation of equilibrium is especially used when the method of section is used. It means in terms of method of joints, our main concern is all about summation of forces, and somehow about summation of moment also is equal to 0. But in case of method of section, we use or cut a selected piece or selected part of the system or the selected unit of the system to solve other than the complete or the rather than the complete structure or the complete system. Main concern for method of section is summation of moment is equal to 0. So in general, the force acting on a section which cuts more than the unknown members of a plane truss cannot be solved for completely because there are only three independent equations of equilibriums. The vector representing a force acting on a joint or section is drawn on the same side of the joint or the section. The member which transmits the force with the tension is indicated. It means if there is a member with tension in it, so we will represent it by using an arrow outward, and in case of a member that is under compression, we will use an equation or a arrow inward towards the joint to describe the position of compression. When the two diagonal members which brace a quadrilateral plane are flexible member incapable of supporting compression, only the one intention is retained in the analysis. When two joined members under a loads or collinear third member with a different direction is joined with their connection, the force in the third member must be equal to 0. So this was all about the main points or the main concerns about the trusses. And we have already solved the numerical problems of trusses, simple and plain. Then frame and machine. Frame or machine are a structure which contain one or more multi-force members. Multi-force member is one which has acting on it three or more forces or two or more forces and one or more couples. So it means in case of frame and machines, if we are specifically talking about frames, frame are structures which are designed to support load in a static condition. It means if in terms of static condition, in terms of rest position, our structure is known as frames. And in case of machines that are designed to transmit force or movement from one part to another part in a motion condition or in a moving condition, it means there are movable part in terms of machine, and in terms of frames they are in static condition members. Only frame and machines which are statistically determinate externally and internally are considered here. They will follow the equation of m plus 3 is equal to 2j. If a frame or machine as a whole in a rigid unit with its external supports are removed, then we begin the analysis of computer external reaction. Forces acting in the internal connection of frame and machine are calculated by dismembering the structure. It means each member is treated as an individual section. To solve the equilibrium condition, the force and movement equation of equilibrium are applied to members are needed to compute the desired unknown. So it means we are going to start with certain known values to find out the unknown values. Basically the equations are the same. Equilibrium conditions are the followed as summation of force is equal to 0 and summation of movement is also equals to 0. So this was all about the main points or the main concerns of chapter number 4. If you have any question, you can ask me. and this material, all this material has been uploaded to your LMS account and open courseware of Compute as well. Thank you very much.